Good evening, everybody. This is Dr. Arunava Majumder. I'm the Assistant Professor of Lovely Professional University and the Chief Financial Officer of Innova World. And today I'm going to deliver the lecture about the engineering mathematics and its important aspects in any project based learning, any competitive examinations, what kind of questions and what kind of answers are required if you are going to appear for any competitive examinations like GATE. So all these kinds of topics, and also for the students that is who are the students of engineering mathematics, that is new engineering students like CSE, okay, and other streams like mechanical, aerospace, and so on. And today, I would like to demonstrate, first of all, that is why this lecture is, there is a learning outcome of this lecture, why it is needed, and what will be the outcome and what we learn after completing this topic. The lecture is actually designed for the engineering students and the GATE aspirants, and for those who want to develop their mathematical skills for application purpose. This lecture would be very helpful for engineering mathematics students who are actually willing to achieve the high scores in exams, and also the GATE is aspirants who want to get good percentile in GATE like competitive exams, or who are willing to develop their skills for mathematical applications for several project purposes. As an example, the problem of image processing. Okay, if a student is actually want to get some project regarding the image processing or signal processing or design optimization in aerospace engineering or mechanical engineering or civil, okay, so all these kinds of problems you need the engineering mathematics the most there. Okay, and this particular lecture is aiming to deliver the topics on all mathematical problems and their solutions based on real life examples. And also, if you are new to this channel, Innova World also offers special boot camps and courses for the freshers and high paid job seeking candidates. You can also find different job positions here and also internships available in our website. Okay, you can, for any query, you can contact the contact at the rate innovaworld.info, or you can visit our website www.innovaworld.info. Now, I'm going to start our lecture today, which is the introduction part of engineering mathematics. And in this lecture, first we will deliver the use of engineering mathematics, which actually includes all kind of applications. What are the applications are available and different aspects like engineering, uh, like optimization problems in finance, in our economics problems, and many others. The detailed topic of engineering mathematics, what kind of topics are covered in this course for engineering students. Okay, that is you can say the syllabus. It actually differs from different university to university, but I will cover all kind of means details and important topics of engineering mathematics, which actually covers all the syllabus from all over the universities in the country. And the important topics for competitive examinations, that is what kind of questions will be there, how to answer this question in short way, and such as gate examinations or other competitive examinations. You can see these kinds of questions are there, and we will practice that kind of questions also. Now, engineering mathematics is the foundation actually of all engineering fields, as I told, and it is the base of, that is, it has a very powerful tool. Okay, different powerful tools like differential equations modeling, differential equations modeling, optimization modeling problems, okay, and many other decision making problems, okay, in logical way. And this presentation we will explore the importance of engineering mathematics in unlocking the complex engineering solutions. Okay, how to solve it, and the different kinds of questions we will also discuss in this lecture. Okay, for any competitive examinations. Now, engineering mathematics, it is various fields, as I already told, and such as mechanical, electrical, civil, chemical, aerospace. Okay, computer science and engineering. So, in every field of engineering, this core mathematics, that is the modeling tools, okay, and the analysis tools, the numerical tools. These are very important there. Okay, and it is generally these mathematical tools are used to model some complex engineering problems. Okay, and what modeling means, model means we if you solve this model, you can have the solution of that particular real life problem. Okay, and also there is some analysis tools are there by using different softwares like MATLAB, like Maple, Python are there. Okay, and for statistical analysis there are softwares like SPSS, like are different kinds of softwares are there to analyze the numerical problems. And we also there are to design some complex systems and processes. Okay, and these examples, it includes the design of bridges, the design of aircraft, okay, design of electrical circuits, for artificial intelligence, to develop some artificial intelligence algorithms. Okay, and decision tree to find any decision making, to find the ultimate, that is optimized decision for decision making problems. Okay, so in all kind of field we use engineering mathematics. So now we will start the first topic of engineering mathematics. That is, today we will discuss the general topic, which are important topics for engineering mathematics. The first and foremost and most important topics is the linear algebra, and it includes the metrics, determinants, and so on. And the application of linear algebra, the first application, what I would like to say, the computer graphics and computer vision. And okay, okay, so computer graphics and computer vision, the most important applications I would like to say. And linear algebra, it is a crucial, it has a crucial task, it can play a crucial task to image some very means important problems of image processing, like image manipulation, okay, 3D graphics rendering, okay, and object orientation, like this. And also the data analysis, okay, data analysis and machine learning problems. What I already told, that machine learning today and artificial intelligence, it is one of the most important topics, okay, in all over the world. You can see industries, they are hiring the candidates who actually knows the AI and machine learning means related algorithms, who can develop. So these kinds of the jobs to develop the machine learning and AI related problems, or to who can solve these problems. Okay, they have the one of the most, means the demand of that kind of job is the most in nowadays. So linear algebra, it is very essential in machine learning algorithms. Okay, where data and it is often represented as a matrix. Okay, every data that is in two dimension, it is represented as a matrix. And it techniques like linear regression, support vector machines, neural networks, okay, decision tree, and this random forest algorithms. These are the one of the foremost, means important applications or important problems nowadays it is going on. And we need the data analysis tools, the machine learning tools, okay, to solve these kind of problems. and that's why the linear algebra, it plays a very important role in here. Now I'm going to discuss about one of the most important image processing example to you. You can see this image. What whose image is this? Okay, you can see that is as a just as a plain overview. You can just ordinate. You can see there's this image. It looks like the U.S. president, Abraham Lincoln. Okay, uh, but you can see what is the picture. This picture is actually very dull. Why? Because of the pixel. The number of pixel here, it is very less. Okay, and as we increase the number of pixel in any picture, the clarity of the picture will also be increased. That we all know already, because if you number of pixel is increased, then the clarity of the picture is also increased. So here, for the sake of simplicity, we have decreased the number of pixel in this image. So now what I'm going to tell, now you can see this particular image has several boxes. This is the these are the box. You can see first box, second box, third box, and different boxes are there. And each and every box is actually it represents a pixel, and every pixel has different colors. Okay, some are same colors, and but some maximum of the pixels are different colors. And each and every pixel, now look at the second image. Okay, here all pixels are quantified. It means that each and every pixel has some numbers. You can see the numbers. So it means this first, this number, it actually represent the pixel number of this particular pixel. And the color code, actually the color of this pixel is actually represented by this particular number. Similarly, for the second pixel, that is this pixel, this is the number for the second pixel. So now what matrix, this is a matrix formation of the pixel. You can see here. So this matrix is actually, it is representing the pixel matrix. And every number here representing the pixel, and this pixel is actually representing the individual color of each and every cell of this matrix, and which will create this actual the original image. Now you can play with these numbers. You can change the numbers. If you change the numbers, the color of this image will be it may be, you can see the overexposed image, underexposed image, how these images are created, actually playing with these numbers. You can change these numbers, and you can just increase the, that is highlight. You can highlight the picture. You can increase the brightness of the picture. You can increase the contrast of the picture. Okay, without changing the image. If just these numbers you can change, so the brightness or contrast you can easily you can manage it. Okay, similarly, if you want, you can increase or decrease the image, that is you can extend the image, you can rotate the image. For each and every cases you can, so that is a vector operation. Okay, for increase, for rotating the image or for extending the image, so that operations are also be used in this kind of cases. So this is the actual pixel matrix and application of main application of matrix. Similarly, now you can see for drone applications, means if you have a drone and you want to pick some picture, you want to take some picture with a drone, and you can fly the drone, and you can take the picture of some locations. And the picture you can see from means a height. If it is a height is, that is altitude is very high, then the picture, the pixel of the that is the picture what you are taking, that picture is also not that much clear in that case. So you can also play with this pixel matrix, and you can also clarify this picture in, you can make the clarity of this picture, okay, in different processes, different by using different tools of this linear algebra. And you can um, means analyze the picture according to your way. Now we will discuss what are the main topics of linear algebra, which are actually important. And this is these topics what I am going to discuss today. That is, these topics, five topics are elaborated here. And you can see the first topic is matrix, determinants, rank of a matrix, a solution of system of linear equations, and the last one is eigenvalues and eigenvectors. All these five topics are very important for the GATE aspirants, for the students who are actually learning the engineering and learning engineering mathematics now. Okay, and you can see different types of questions, and these topics are the important topics. Okay, for examinations also, in your semester or your university examinations also, and also for competitive examinations, and also for the project based learnings. Okay, these tools you can use, okay, in your projects, okay, for to solve the complex mathematical problems. Okay, and the first one is matrix. The already we have discussed, and how matrix is used. Okay, by using that pixel matrix for that particular image, I've already discussed in the previous slide. Okay, and now in this, sorry, rank of the matrix, this is very important topic for exams. Okay, many questions you can find from this rank of a matrix. Okay, in gate examinations also, in the semester examinations also. And solution of system of linear equations. Okay, it has many of some equations. System of linear equations, it means that one or more, sorry, two or more linear equations are given to you, and you need to solve that system of equations, and you need to have a solution. Okay, some equation, system of equations has solutions, some equations does not have the do not have any solutions. Okay, so it depends on what kind of problem is this, and you have to use some mathematical tool to solve this kind of problems. The last one is eigenvalue and eigenvectors, which is also another very important topics for engineering mathematics. And I would like to discuss about this eigenvalues and eigenvector problems. Okay, this one, and this actually represents, that is, I'm explaining this. Suppose a vector, that is, I am applying a force. Okay, applying a force to a body, to a particle. Suppose this is a particle. Okay, after applying the force, this particle can change its direction to any other direction. Okay, or it can also go to the same direction. Okay, it depends on what kind of force we are applying and which direction we have applied the force. Okay, it depends on, depending on that, this particular uh, particle can change its direction, or can have the same direction. Okay, moving but can have the same direction. Okay, so eigen vectors are only that kind of vectors if the direction of this particle is not changing after applying the force. Okay, so, and if it is changes, if the direction is changed, then this particular vector we will not say it is a eigenvector, but this particular vector, this will be the eigenvector. Okay, and the magnitude of this vector, it will denote the eigenvalues. Okay, depending on this eigenvalues. Okay, so we will discuss all these kind of detailed topics in the next lectures. Okay, but today it is an introductory part, and I will like to discuss all introductions and the applications. Okay, all of these topics. So that is why am just going to explain that what is applications and how to use this. The detailed part I will discuss in the next lectures. Next one is calculus. This is another important topics. Okay, many of you already learned calculus in previous classes, and the applications of calculus basically in engineering applications are there. And the use of calculus is to design the complex systems, to make the bridges, buildings. Okay, calculus helps the engineers to optimize the designs, the behavior of the system, and you can see the when we build some bridges, when we build the buildings, okay, and that is different kind of forces are applied there, okay, and that kind of forces is actually we use the techniques of derivatives, we use the technique of integrations, okay, to analyze that kind of system. And second one is another most foremost important topic, which is computer graphics. Okay, so it is another very crucial role in graphics played by the calculus. Okay, helping them to model the curves, surfaces, animations. Actually, there are uh, in detail when we will discuss the detail. I can explain there, but now I'm just giving you an introduction how to use in curves when we draw something. Okay, we draw either a straight line or some curves in computers. Okay, so if you want to find some curves are there and we want to find some area under this curve, or if you have some particular type of model, okay, and you want to find the area of the surface of that model, then calculus will help you. This is actually uh, the surface of the model. It means the area of the surface. If you want to find out the volume of any particular model, that is, it may be any kind of structure, you want to find the volume of that. Maybe it may be some bottle, it may be some oil tanker of any particular of any aircraft. What is the volume of that? What is the surface area of that? Okay, so surface area, we have to analyze the surface area. We have to find out the surface area. Why? Because when we are painting, okay, we're painting the surface. Okay, we need to optimize how much color is to used there. So for that, we need to find the surface. So this calculus will help you to find out the volume, this kind of techniques. Okay, and also the techniques like rendering, okay, shading in means in computer graphics. Okay, the calculus will help you there also, simulating the lightning and shadows. Now we will discuss about the main topics of calculus. What are the means you have to learn the here differential calculus, which is actually the part of differentiation, that is derivative, different types of derivative of different types of functions. Integration, okay, many integrations rules are available, and you have to means learn the rules to find out the integration, and this integration actually will help you to find out the surface, okay, and the volume, and many other applications are there, okay, in probability, in economics, and many applications are there. Integration, it is a very crucial tool to find out the any to solve any kind of practical problem. Next one is Rolle's theorem. Actually, this theorem is applicable for optimization problems. Okay, to find out the maximum or minimum value, okay, of any model. Okay, so actually, when some complex engineering problems are modeled, or some curves, complex engineering functions are curved, or that curve may be 2D or maybe 3D, the Rolle's theorem helps you to find out the Rolle's theorem is used to find out the optimized value of the curve. Okay, mean value theorems are also there. Okay, so and these theorems are suppose are using in many kinds of problems. Maybe you can consider any financial problem or economics problem. Companies, all companies, their target is to analyze the profit and loss. Every company, there is a their attention is to either find the maximum profit, or to minimize the cost, that is minimum cost. Okay, so how to achieve this profit, or how to achieve the minimum cost? There are many kinds of costs are available there, that is companies has to incur many type of cost, maybe set up a building, to set up the machineries, okay, for workers, the wages of the workers, many costs are there. and there is a variation of the market demand is also there. So how to find out the means optimum profit, that is what kind of strategy a company should adopt so that they can maximize the profit. So there you have to find out a equation which is called mathematical modeling. You have to model that kind of modeling, the profit or cost modeling it is called. Okay, under many constraints, that constraints may be budget constraints, maybe the space constraints, company has many limitations. Okay, so all of this, considering all of these constraints, we need to find out the uh, we need to maximize the profit or minimize the cost. So all these kinds of things are actually uh, uh, taken by this calculus problems. Now differential equations. This differential equation is the most particular. What I say, it is a very popular modeling examples. In any real life examples, any fluid dynamics, celestial mechanics, classical mechanics, aerospace engineering, mechanical engineering, everywhere the modeling of differential equation is important. That is, we must need it to model by using the differential equations. It may be ordinary, maybe partial differential equations, but we have to model it by using the differential equations. Okay, and you can see in classical mechanics, differential equations describe the motion of the objects. Okay, under the influence of many forces. Okay, Newton's second law you can consider. Okay, in fluid dynamics, Navier-Stokes equations are there. The behavior of a fluid in different conditions. Okay, if a fluid is flowing, if I just put an object, okay, inside the fluid, or I want to resist the motion of the fluid, then what kind of behavior will be there in that fluid. So all kind of this kinds of motions, what is the motion if the fluid motion is very high, and if we put an object there, then what kind of behavior will be there in that fluid. So all these kinds of modeling, that is we need to make a mathematical model, and that mathematical model will use the differential equation, okay, under various conditions. And after we solving the problem, we can you can analyze everything, that is the motion and everything of the fluid, and we can have different types of solutions. Okay, and we can apply this to means model different types of that is dams are there. If fluid is there, then we can suppose we are going to build a dam. Okay, then we use differential equations to optimize, that is what is to analyze the behavior of the fluid if a dam is constructed, okay, and between a river. Similarly, aerodynamics, okay, in aerospace engineering to make a aircraft, okay, differential equation is needed there. Okay, hydrodynamics and many more. Similarly, for celestial mechanics, okay, the celestial bodies and their behaviors and their interactions, all these kinds of things are they are using differential equation modeling. Now, what are the topics of differential equation we will learn here? First order differential equation. Actually, differential equation has two kinds of differential equations are there. First one is ODE, ordinary differential equation, and the second one is PDE, partial differential equations. Okay, so first order differential equations, here what we it is actually basically ODE. I'm talking about the ODE here, first order ordinary differential equation. Okay, higher order ordinary differential equations. Okay, first order ODE and first order PDE both exist, but basically in your topics, that is engineering mathematics, in most of the universities and in gate exams also, the first order and higher order ODE is most important there. PD is also important, but these first and higher orders ODE are more important. Okay, system of differential equations means one or more differential equations are there. Then what will be the solution of the differential equations. Okay, that is a system of differential equations. Partial differential equations, that is PDE. Here also first order and second and higher order partial differential equations are also there, and we will also explain both differential equations ODE and PDE. Okay, basically in modeling, in real life modeling, real life forecasting, that is PD is the one of the most important to model any real life practical problems. Now another important topic is multivariate calculus. Okay, this multivariate calculus is specially designed for optimization problems. Okay, when that is already I have discussed about the optimization problem in company profit and loss. Okay, in profit and loss calculation, that is this kind of you can see here the graph. Okay, this graph, so you can see this is you can suppose that this particular function, it may be it is there are many peaks are there. Okay, there is a peak. Okay, let me change the ink color. There is a peak, here is another peak, here is another peak. Okay, many peaks are also there, and many bottoms are there. Here you can see there is a bottom line. Here in between any, here there is a bottom, that is the minimum point. Here also another minimum value exists. Okay, so this particular image has some minimum values also and some maximum values also. Now we need to find this minimum or maximum values. Okay, and it depends actually when we are this particular image or this particular graph, it is generated by some softwares. Okay, and this software actually after generating this software, there is image, we can easily find out which one is the maximum or which one is the minimum. But basically you can see these maximum or minimum actually local, not the global. That is the not, we cannot say that this is highest or not. It is the actual originally the maximum or of all the maximum values or not, because there are many maximum values you can find. Okay, so how can you find it? Okay, so and these particular models, that is this is called optimization modeling. Okay, and this particular optimization model is an optimization model, and this particular optimization model, it is generally generated not only for the for this problem, that is for only economics problems. It is also can be generated in any other engineering problems also. Okay, and in any optimization problem, this kind of graphs are generated. It is a 3D modeling, a 3D graph. So these types of graphs are generated, and we need to find out the maximum or this minimum values. Okay, and this modeling, it is other examples are in aircraft design. Okay, in any other design of any machines, new machines. Okay, you can in optimize when we optimize the design, that is optimal design of an aircraft or optimal design of a ship or optimal design of any other model. Okay, 3D model. So this kind of curves, or sorry, this kind of 3D curves, 3D graphs are generated there, and we need to find these values, these optimal values. Okay, and these values are means very important decisions we can make if you find these optimal values. Now what are the applications in optimization? Multivariate calculus and economics and finance already we have discussed, and also to model the multiple 3D objects in computer graphics. Okay, transformations, lightning, shading. Okay, all based on mathematical principles involving the multivariate calculus. Now in this particular topic, what are important reading topics are there? Functions of several variables. Okay, function of several variables made, already we have learned, you can in your previous classes. Function of single variable you already know, that is only y equal to f of x. Okay, which actually one dependent variable, sorry, independent, this is the independent variable, independent, and this is the one dependent variable. Okay, in multivariate there will be the functions like z of f x y, that is independent variable will be 2. Okay, and in this kind of functions, in function of single variable, there will be a curve will be generated like this. And in two independent variables, when there are two independent variables, there the that will be a 3D image. There is a 3D surface will be generated like this. Okay, already we have shown the surface, that is the surface will be like this. Okay, and x and y is actually in function of single variable. This is the x-axis and this is the y-axis, and in two variables this will be the z-axis, and this is x and this is y. Okay, so z-axis is actually the dependent variable, the dependent axis which is on the horizontal, and two vertical axes x and y will be there, and a surface will be generated here like this, and it will be a 3D graph. And similarly, when function of several variables, we will generally talking about this particular, when two variables are there, actually our study will be on 3D graphs here basically. Yes, it may be 4D or 5D. Function of several means there may be 4 or 5D graphs, that is when the number of independent variables will be 3. That is, I can say, that is f equal to is f g equal to f of x y z. Three independent variables will be there, but in three independent variables we cannot visualize it, but it exists also. Okay, so we will learn different mathematical tools to solve this kind of problems. Okay, our second topics are limits, continuity. Okay, in upcoming lecture we will all discuss about it. Okay, or in detailed discussions will be discussed in upcoming lectures. Okay, today it is just introductory. I'm giving you the main topics, what we will learn. Okay, the total differential and chain rules. Okay, directional derivatives very important, and gradient vectors. Critical point finding and optimization. This is also important. Multiple integrals. Okay, which includes surface integrals. Okay, volume integrals are also there, and there is a line integral also. Okay, all these topics they're actually are the topics of multivariate calculus. Yes, in some university syllabus you can find the line surface integrals and volume integrals are given as a different topics, but it is actually multiple variables are used there, so actually we can include them in multivariate calculus. Now the last one is a Fourier series and transformation, basically used in signal processing, and one of the most important topics and signal processings, also aircrafts. Okay, and Fourier series, it is generally extensively used in signal processing when the signals are generally whatever here we can see, that is you can see this picture. Okay, smooth signals, a sine curve or cosine curves are there. Actually signals is not, original signals are not like this. Okay, and we need to actually make the signal smooth by using the Fourier series, then our calculations will be too much easier. Okay, if you use the Fourier series is actually the approximation. Okay, the original signal is approximated by the Fourier series. Okay, the original signal is not like so smooth curve. Okay, we have to make them smooth by using this Fourier series, and then we need to calculate and we can analyze the signal then. Okay, so this is the main purpose of the Fourier series. And transformation is actually, Fourier series is an integral transformation. Okay, and we will discuss later about, I am not going to talk about means mathematical and means explanation part today. Okay, the next topics will explain everything, and generally the basic topics, that is applications are signal processing. Okay, fluid dynamics, it is used in analysis of fluid flow, also we use the Fourier series, and understanding the phenomena like turbulence. Okay, and this kind of this turbulence and everything in aircraft engineering, okay, and aerospace engineering, these are there is the use of Fourier series is there, okay, to analyze the turbulence. Okay, medical imaging techniques like MRI, okay, Fourier transformation is used there. Okay, Fourier transformation is used. Okay, Fourier series is different, transformation is an integral transformation. This is used for to means simplify the problem. Okay, integral transformation. Okay, so in MRI, that is this medical problem or in medical application, Fourier transformation is used to create the images from signals received from the body tissues. Now, what are the main topics of this Fourier series and transform? The approximation, basically, there are not too much topics are there. The approximation and signals, that is, if a signal is there, okay, that is a haphazard signal is there, original signal is given to you, how can you approximate that signal to its Fourier, that is approximated Fourier series. This is the main topic here. Okay, and some conditions will also be satisfied for this, which is called the Dirichlet conditions. We will also learn that. And another one is Parseval's identity. Okay, and these three are the main topics of Fourier transformations. Okay, so all these topics, these are the important topics of engineering mathematics. Yes, some other many other topics are also there, and we will also discuss that topics also. uh, but I will make some different slides for that. That is, in engineering mathematics, numerical methods are also there. Okay, and the engineering probability statistics are also there for gate examinations. Numerical methods, probability and statistics, discrete mathematics, discrete structures. Okay, all these kinds of courses are also there, but I am not including them to basic uh, means engineering mathematics course. Okay, so we will learn all that kind of topics are there are also, but in different courses. Okay, so we also offer the get coaching for any customized subjects. Okay, if you have any query for any of customized subjects, like totally separate gate coaching for aerospace engineering or computer science and engineering or civil or mechanical, then you can just put a message in the message box, or you can contact us with contact at the rate innovaworld.info. You also can visit our website www.innovaworld.info. Thank you uh, for attending this lecture. Now, if you have any further doubt, then you can ask. Okay, next class will be intimated shortly. Okay, and everything that is, I will share everything for the next class very shortly. Okay, we need to means design the course for what kind of learning, that is all kind of learning outcomes. Okay, and it will be informed shortly.